Welcome to Architecture and Design for Society 2026. All right, my name is Nidipong Papapankun, a lecturer from the Department of Architecture. It is my honor to be here serving you guys as the MC today. Thank you very much for coming today. Now we are at the fourth consecutive year of a lecturer series. This series brings speakers from Thailand and around the world to share their knowledge, experiences, and experience in design and research that engage with the society and also give it back to society as well. All right, so before we begin, I have a small news for you guys. For the attendees who are licensed architects and also the professionals in the related field, you can earn the CBD points by simply registering and attending the session. All right, so moreover, if you join more than 80% of the lecture in these semesters, you can receive the certificate of completion and also get the credit that you can even go through the coursework if you later enroll the program of the faculty of architecture at Chulalongkorn University. All right, so next I would like to announce the sponsors of these events tonight. We would like to thank Sekun Thai and Gulf Thailand for generous support in making tonight possible. Okay, next, before we begin, please join me in welcoming our Dean, Assistant Professor Surayut Sapsuk, to say a few opening words and welcome our speakers.
So again, good evenings and welcome to Faculty of Architecture, Chulalongkorn University. So I think I haven't seen each other for a while. So this is just starting of the semester in our school, and this is a very good day for our first lecture of this season. So this season of the public lecture marks the story about SDG, because in Thailand now, I think we have to think about a lot on the climate change and also the adaptations of the built environments that we have in our culture. Especially if you heard the news this morning, there's a big flood in Nan area. It's very scary, and that's some things that happen because we are not so carefully with our environments. So the whole series of this lecture series for this year will contribute to the design and all of the creative things that lead to the SDGs and environmental issue of our countries. It's a very good night today that we have a very special guest starting the lecture with, and all of them is a representative from Mitsubishi Jisho Design, which is the Japanese company, and also have a branch in Singapore. Their work may not so well known among us because if we think about Mitsubishi in Thailand, we are also think about the electrical equipment or even a car. In the past, you didn't produce car anymore, right? Yeah, now. But in fact, Mitsubishi done a lot of businesses in the world, and one of the very special part is that the design is not only a design of architecture but also the urban design as well. Because I think in the last few months they come to discuss with us and explain to us about doing the urban design guideline for the whole area of the Tokyo station in Japan. A big place for if you walk around. If anyone have ever been to Tokyo Station in Tokyo, you see that a lot of developments, urban development, which is very nice area to walk around and to solve a lot of problems of their a big node in the city. That's also done by Mitsubishi Jisho. But the subject today that we are going to discuss about is a very small thing, but it's very important because it's about the wood constructions. Our faculties drive a lot on the promoting the use of wood in our construction in Thailand, because we think that Thailand needs to use a lot of wood now. In the past, we just shut off the forest because we are just afraid that we're going to lose a lot of wood resource and forest resource that we have right now. But I mean, think twice. Now it's time to encourage the construction of wood again, because if we use a lot of wood, it will create a demand of wood, and by the demand of wood, we can provide a lot of supplies of wood, and it means that people can starting to do the forestation instead of monocycle of crop in the outskirts of the countries. So I just don't want to waste the time, but after this lecture, if anyone, have a visit the tea pavilions on the second floor, today we're going to discuss about that subjects and how to design that wood pavilions in a free-form shape, building by wood, a part of wood. And after this, I encourage you to walk around and see, and we already have a designer here so that you can discuss in the detail of that things. So again, I would like to thank our guests from Mitsubishi Jisho Design, and also would like to thank our big sponsor, Sun Thai, and also Golf, which is our new sponsor. Thank you very much.
Thank you very much for our Dean. And next, I would like to introduce our speakers. Our first speaker is Mr. Kentaro FURUYA. Mr. Kentaro FURUYA is the General Manager of the International Business at the Mitsubishi Jisho Design. He is a registered architect in Japan for 20 years of experiences in design of the building in US, Japan, and also across the Asia. Can you please give big round of applause for our first speakers? And next, our second speaker is Mr. Yusuke HOTTA. Mr. Yusuke HOTTA is the Chief Structural Engineer at Mitsubishi Jisho Design. He is a licensed architect and engineer in both US and Japan. Also, Mr. Yusuke is experienced in design of safe, high-rise, and earthquake-proof for the building. And yeah, please give the big round of applause again for our second guest. And next, our final speaker, Mr. ATSUMI. He is the manager and architect in design studio at Mitsubishi Jisho Design. And he is also the creator of the world's first 3D printed wooden building. Okay, please give the very big round of applause for our final speakers tonight. All right, and just before we dive in, I have a small request for you guys. Please try to keep the conversation and also the noise in the minimum to respect our guests. All right, thank you very much for your cooperation, and please enjoy the lectures. Yes.
Okay, good afternoon. So my name is Kentaro FURUYA. I'm from Mitsubishi Jisho Design. So today's topic is about exploring the potential of wood, practice and experimentation. So Mr. HOTTA, the structure engineer, will talk about the practice side, and Mr. ATSUMI is talk about the experimentation side of the wood potentials. So before we go into the presentation by Mr. HOTTA and Mr. ATSUMI, I just wanted to go over who we are. So as Dean mentioned, that there's so many Mitsubishi in around the world, but actually there are more than 600 Mitsubishi-related companies, but they are mostly all independent. We don't have a legal relationship to each other. It's because after the World War II, it was dissolved into the separate companies. So among the major companies, Mitsubishi Estate is one of the major Mitsubishi company, and we are the engineering and the architecture design arms of the Mitsubishi Estate. So we call ourselves Mitsubishi Jisho Design. And what we do is So this is our statistics. We are about a little less than 900 the staff, and about half is the architect. And we have all the engineers, consulting, so we do all type of the tasks of the architectural design or engineering design. And so these are some of the projects that we do. And what we were founded back in 1890s, about more than 130 years ago. And as also they mentioned about the area in front of Tokyo Station, it's called Marunouchi area, and that's the CBD of Tokyo. And our mother company, Mitsubishi, the Mitsubishi company, have bought this land, 120-hectare land, to develop the first CBD in Japan. So we invited an architect from British, but at that time Japanese didn't have any architects. So we learned from the British architect to create the London-style brick buildings. And then in later 1900, we started the reinforced concrete buildings as well. Then, so there are several phases of redevelopment of Marunouchi area. And now we are working today, we are actually working on the tower of about 400-meter tall, which is expected to be completed in 2028. So why? So it is because we have started out with, so Mitsubishi Jisho Design as one company. We designed a brick building, reinforced concrete buildings, steel buildings, and all those. But as the current situation of climate changes, we are trying to explore other method to reduce the carbon emissions. So one of the answers that we are seeking is the timber structures, the use of the wood into the buildings. And Mr. Hotta is talking about the actual implementation of the timber structural design. And that's one of the biggest project we are working on. Then on the other hand, Mr. ATSUMI will talk about more smaller scale, the tea house you see on the downstairs. So looking at the potential of other implementation of the wood as a material. So now I'll just hand it over to Mr. Hotta about the structural design.
So very nice to meet you. Again, my name is Yusuke Hotta. I'm a structural engineer of Mitsubishi Jisho Design. Actually, I joined this company around 20 years ago and starting my career. So sometimes I design structure, providing the structural engineering service for the steel high-rise, and sometimes I provide working for the concrete high-rise. But recently, I'm very keen on to design and develop the possibility of the timber structure or timber steel hybrid structure. So today, I would like to talk about my work regarding the timber steel hybrid structure and why we are now keen on the timber structure engineering. So my presentation has been started with what is the history of our timber. So for both Taiwan people and Japanese people, I feel timber is very familiar material. So looking at the Taiwan traditional buildings, many buildings use timber, and sometimes the timber play very artistic appearance. And looking at the Japanese traditional architectures, this is the Imperial Palace in Kyoto. This building also adopting the timber structures. And this is also the temple in the Kyoto. Japanese people is very familiar with timber traditionally. And I think both Taiwan people and the Japanese people feel timber structure about the heartwarming appearance, and sometimes very easy to making some artistic appearance. And even looking at the modern Japanese timber structure, timber buildings, this is actually my first timber work in my career. Also, this kind of the heartwarming or warm appearance and texture is very accepted by the client. And also, this is another project we are worked on more than 10 years. Also, the heartwarming appearance is one of the motivation to adopt the timber structure. So this is the interior of the cafe, having around 100 square meters. And the people is enjoying the coffee or tea inside and feeling some kind of the very mature mood. And also, this is another our project, collaborating with architect Kengo Kuma. Even modern timber structure, the structure can be can express very artistic appearance as well as the traditional sculptural architectures. But today, we would like to think about why timber structure is trending all over the world now. So, except for Japanese or Taiwan people, timber is not so traditional familiar material. Not always familiar materials. However, nowadays, all over the world, people is very interested in the timbers. So one of the reasons is current trend of the timber is, for instance, this is Taiwan government's goal in 2050s. So all people is now very concerned about the global heat warming. So, and we need to we try to reduce the carbon emission and prevent further global warming. So we are looking for the good material to construct a building now. So, and comparing the carbon intensity between timber, concrete, and steels, this is the carbon intensity tracked out from some website. Steel exhausts so many carbon during its producting. However, the timber, even it's a glulam timber or CLT, the carbon intensity is much smaller compared to the concrete and the steel. That's why people is very interested in utilizing the timber. And another aspect of the timber can absorb the CO2 in the air during its growing. So, and after 30 years or 50 years after planting, they stop absorbing the CO2 and using the oxygen rather than absorbing the CO2. However, that grown timber is shipped to the city and changed as the timber building, and the new plants, new trees planted in the forest and creating the sustainable forest. It means city can stock the carbon, and we can create the unlimited carbon CO2 absorption in the forest. That's why people is interested in using the timber as much as possible. But in this scheme, the sustainable forest circulation is essential, actually. But in any case, based on this kind of the concept, people, for these 10 years, 15 years, people is very keen on to creating the timber buildings as big as possible and create like this. So previously, all building is constructed using the concrete or steel, but trying to replacing the concrete or steel to the timber, we can reduce the carbon emission in the city. So this kind of the motivation create the mass timber kind of the competition all over the world. So, and this is a few years ago, I created the ranking in the world. So currently the tallest mass timber reached approximately 200 meter tall, which this is the project in Australia, concrete timber hybrid structure. And some of mass timber project is provided by our company actually. And now I'm working on this one under construction, steel timber hybrid structure, and expected to be the tallest timber steel hybrid structure in Japan when it is completed. But anyway, that's kind of the seeking of the green material invite this kind of the mass timber competition. And currently, there are so many tall timber buildings in the world. But when we design this kind of the mass timber structures, there are three topics to discuss. The one is how we maintain the structural stability. And actually, timber is a combustible material. So how we maintain the fire safety under the fire. And also timber is an organic material. So after the construction, starting the decay, so how we maintain the quality of the timber. So that is kind of the durability issues and the maintenance regime issues. So for structural stabilities, recently this kind of the engineering route is well developed. So for instance, a CLT, cross-laminated timber, or glulam timber, or laminated veneer lumbars can provide very strong material property. Then this kind of the material development can make the tall mass timber building possible. So in order to maintain the structural stability, we positively use this kind of the engineering route. That is a solution of recent trend. And for second issue, fire safety, actually timber, even though timber gets ignited by the fire, it's very hard to keep burning. So once timber gets char layer, the heat release ratio is heat speed is decreased. Then, so considering this kind of the char layer and maintain the fine section until the firefighter distinguish the fire, building can keep its stability. So this is kind of the international trend considering the char layer design, and most timber high-rise accept this kind of char layer design and creating the mass timber project. However, this concept is very traditional and accepted in all over the world, but some fire engineers are allowed to relying on this concept too much is dangerous, because this is the picture after the great earthquake in Japan in 1923, called the Great Kanto earthquake. So in this age, most building is made of the timber, but weak timbers. So when the earthquake hit the building, many building collapse, and the earthquake occur around the noon. So many people is cooking in the kitchen and start igniting the fire, and the district fire is growing very rapidly, and the whole district is burned out. So, and also when the timber volume is exceeding somehow limit, the growth of the fire is very fast. So for near future, maybe we need to take care of fire safety more, and some more additional research or development would be required for fire safety. However, we also need to think about this kind of the large fire. So for that solution issue, Japanese timber manufacturer developing some kind of the new fireproofing woods. So adopting this kind of the fireproofing wood could be one of the solutions for mass timber. What is a component of the fireproofing wood is this is a structure section surrounded by plasterboard, and another finish layer is applied on the plasterboard. So even though under the fire this layer is burned out, this plasterboard can stop the development of the fire. Then after the 2-hour heating, inside is 100% fine. So fire safety still we need further discussion. However, depend on the situation of the building and the timber volumes, we already have some kind of these solutions. And the durabilities, as far as the timber is inside the buildings, this is our project, and the picture is taken after the 10 years after of the building completion. However, no color change and no cracking on it. So as far as the timber is using inside of the building, we don't need to concern too much. However, once the timber is exposed to outside, meaning the getting the rain atmosphere or having strong sunshine, timber is easy to change its colors and sometimes make cracking. So if we design some timber project, mass timber building in Thailand, we also need to take care of this kind of the durability. So, but so far, thanks to the trend of the mass timber competition, this kind of the research is well stocked, and many know-how is accumulated in the world. So based on this kind of the new knowledge, I would like to introduce one project of mass timber in Japan from now. So the introduced project for today is the mass timber building having the 100-meter tall and expected to be the tallest in Japan. Actually, this building is for the insurance company's headquarters and facing to Imperial Palace and locating just in front of the Tokyo Station. And currently, the timber erection has just started and expected to be completed in 2028. This building's plan, typical floor plan is like this, having the 12-meter distance between columns and maximum 16.4 meter distance between columns. And the overall plan shape is 80 meter by 80 meters and having some patio at the center of the plan. And the building height is 100 meters from the above grade and having 19 stories. Actually, the occupancy of the building is mainly the headquarters of the insurance company, and office is located from level 6 through level 18. And the timber is adapted for the column and some ceiling. And the timber column is located above level 6. And CLT appears as a ceiling at the perimeter of the typical floor of level 6 to level 18. Okay. And this is a structural frame rendering. So actually, the maximum span reached over 60 meters. So we gave up using the timber beam, considering the beam penetration or MAP coordination. However, for this project, timber is used for the columns, and the column is connecting using the steel beams. So for typical floor, we have the 52 columns. However, 40 of 52 columns is designed using the timbers. So timber is carrying very heavy gravity load during the building lifetimes. So how we maintain the structural stability during the building lifetime is for figure out the section of the timber's column size. We play some structure tests and measuring the strength and the behavior on it. And finally, we reached to design these columns with 900 square to maximum 2060 by 2060 square. Because timber is an organic material. So even once the continuous loading apply on the columns, timber columns, timber starts shrinking until the load is removed. However, the pressure is low. That kind of the shrinking is very ignorable. So in order to minimize the compression, we tested some structure tests and find out what is the appropriate timber sections. However, when the timber section is over 1 meter by 1 meter, it's very hard to producing. So actually, the timber column is divided into 4 pieces and bundle it on site, like this. And each column size is like this. So 4 column into 1, then maximum over 2 meter by 2 meter square column is achieved. And the second issue regarding the fire safety, for this issue, we also tested some fire igniting tests, expecting a sprinkler effect. And the CLT is locating at the perimeter of the buildings, but keeping the high ceiling height and testing the sprinkler effect, then we confirm the safety during the people's evacuation. So based on our calculation, people in this floor can egress from the floor in no less than 6 minutes. So during the 6 minutes, we prevent the fire reach to the ceiling, even though we have the combustible wall or columns located nearby the ceilings. And as for the durabilities, as you can see this rendering, some timber is exposed to the air. But this is very strong design concept provided by architect Renzo Piano. So we think about how we keep this appearance during the building lifetime. And the conclusion is we provide them some detachable cladding layer. So during the building lifetime, the structural timber is covered with a timber clad. And also we tested some treatment for these timber clad. However, even though this protecting is decayed, we can replace the clad and change it to a new one. And keep the appearance if client required. But anyway, designing mass timber is kind of the trend now. However, to design the mass timber building, we have some issue to solve. And so far, in any case, we have some solution, as I introduced today. And finally, the building shows this kind of the interior or this kind of the interior. So far, I feel first trend of the mass timber is almost terminated. And many engineers and architects is move on to the next steps. So what the next step is, the phase one is kind of the challenge, how big or how attractive timber structure we design. However, the initial concept to adapt the timber is how we design the ecological buildings. So this is some quick calculation of the embodied carbon, compare pure steel structure assumption to timber steel hybrid assumptions. So as you can see, this is the embodied carbon per square meters. So actually, this is the Tokyo Marine project. The higher building goes, the efficiency is slightly changing. The lower one is a mid-story timber steel hybrid buildings for commercial buildings. For these buildings, assuming the pure steel structure, the structure shows around 550 kilogram CO2 per square meters. Then some steel column and steel beam is replaced by the timber. The overall embodied carbon is reduced to 430. So this shows a 20% embodied carbon reduction. However, the building scale is larger. We gave up adopting the timber beams. So in this case, only 7% embodied carbon reduction is provided. So for the future timber structure, we need to find out what is the appropriate planning and what is the appropriate scale to adopt the mass timber. So I think this is so maybe 2028, 2029, many mass timber tall building is showcased in the world. However, for next 10 years, maybe some scale gonna be slightly smaller, or some structural system is more sophisticated, considering this kind of the calculations. And also, talking about the embodied carbon, using the timber is just working for this portion, very early stage of whole life carbons. So talking about the whole life carbon is divided into three phases. This is the upfront carbon phase, is the constructing phase, and the second phase is a building lifetime. So air conditioning efficiency or sunshade efficiency is working this phase. And finally, all building get some demolition phase. So how we reuse or recycling the material is the last phase of the whole life carbons. So far, the phase one is just looking at this upfront carbon phase. However, we have so many mass timber projects in the world. So 50 years later or 60 years later, some of the mass timber projects have been demolished. But if all that kind of the timber is provided to the waste, it means nothing. So how we keep using that kind of timber is another topic we need to discuss. And even though the upfront carbon phase, we still have room to discuss about. One is we need to think about the producting process once again. So this is the chart describing the producting of the CLT or Guram timbers. So the producting is start with the lumbering and the cutting into the laminar and drying and preliminary screeding and gluing, and after the gluing, secondary screeding is applied on it. So during these process, we have so many waste, such as a sawdust or some cutting edge. But currently, these waste is sometimes used for the fuel for the dryings. However, I think we have some more room how we use this kind of waste more efficiency. So former presenter, Mr. Atsumi, will provide some possibility how we reuse this kind of waste. However, for the next step, we need to think about, we need to rethink about and relook at this kind of the producting process as well. And also transporting process at the upfront carbon phase, there might be some room to optimize. So currently, if we have the timber project in Thailand, Thailand unfortunately doesn't have the structural timber manufacturer. So maybe the major timber market is in the Europe or Canada. So if we get the timber from these regions, the timber is shipping using very long distance because the timber is so many volumes. So timber cannot ride on the airplane. So just using the bulk ships. So ship is sailing many distance. But so thinking, we need to think minimizing this kind of transportation. So actually, I'm from Japan, so I would like to appeal the Japanese possibility. So if the timber is imported from the Japan, compare the distance between these two, which one is more efficient? The maybe answer is very clear. But anyway, for the next step, we need to think about the circulation and transportation as well as how we use the timber efficiently. And at the final phase of the whole life carbon, as I mentioned, we need to think about how we demolish the timber. So using the same section and the same timber to next building is one of the options. However, even though the timber is cut and making some chips, we need to, there might be some idea to reuse that kind of the chip or waste or demolished timber. And for the small circulations, currently the timber is a global booming, and the Canada and the Europe and the Japan is a major timber market. However, minimized circulation is very important. So for young engineer or young people, I would like to say, look at the local materials. So for instance, the rubber trees, currently the rubber tree is not used for the structural timbers because of that's the weakness or some disadvantage. However, idea can conquer that kind of the issue, and idea and the thinking can provide any idea to create new products. So as for the closing of my presentation, I would like to say the booming phase one is almost terminated, and now new idea is very welcoming for timber design market. Thank you very much.
Thank you, Hoda-san. From now, I'm going to talk about what about the using wood waste for the 3D printing. And thank you for coming here today. And I'm ATSUMI from Mitsubishi Jisho Design. And today, title is regenerative wood. Evolving the traditional joinery through digital fabrication. So today's there's three key themes. So first is the wood waste as a new architectural material. So how are we going to utilize wood waste for the 3D printing? And then traditional joinery means digital fabrication. So we can learn from traditional joinery for the new technology utilization. And also as a final, it's for regenerative wood architecture. So how we create a circular model or upcycling model for the upcoming emerging tech architecture. So quickly about my profile, I'm ATSUMI, and architect and creative director of Mitsubishi Jisho Design. And before I joined the Mitsubishi Jisho Design, I used to work in Bjelke News Group in Copenhagen, people call BIG. And after that, I worked at the So Fujimoto Atelier Paris, and I joined Mitsubishi Jisho Design. And my work mainly a design strategy for the architecture and urban design, and also research materials, and also many R&D projects as well. And so firstly, I would like to introduce Tsuginote Tea House. So probably you already saw the what is this tea house at the downstairs. And I'm a designer of this Tsuginote Tea House, and it was the first wood 3D printed architecture in the world. So as you can see, this old structure made by desktop 3D printer. It's not like a huge architecture scale 3D printer. So anyone from here can actually create this if you have a 3D printer at home. And all the material is made by wood waste. So I wanted to put this first artwork at Tsuginote Tea House in a very traditional Japanese environment and nature, because I wanted to make some kind of like a contrast between innovation and tradition. So as you can see, this organic curve envelope was actually created many different components, and all the panels, this is 3D printed panels, and all the panels is double curved, and also has the very complicated Japanese joinery as well, and all assembled together in one piece. And also we didn't hide the panel joinery, and because like a joint itself, it's actually a part of the very important aspect of this artwork. And all the panel has ID number. For example, this is a J13. So when you want to assemble all the 3D printed panels, we just need to follow the number. And then by following the number, you can reach to this envelope in 2 hours construction. So another example is what we call the warp. We designed and also produce and construct for the Dubai Design Week 2024. This is much more complicated than the Tsuginote Tea House. And we made more like, how to say, we made much more efficient or clear production workflow for the future utilization of the 3D printing architecture. So the concept of the warp is something creating between innovation and tradition. And we wanted to provide T-space for the emulated people and experiencing the time travel between Japan and UAE. And so people can have the immersive T experience between tradition and innovation. And as you can see, all the components are 3D printed, and all the components has different shape, and all the components actually have the ID number. And we could construct the warp T house in 10 hours by 8 hours around 10 people in the outside. So this is a result of the warp. So this envelope is very, very complicated and but sometimes smooth, double curved design surface, but all made by desktop 3D printed wood panels and joined by traditional Japanese joinery and control and also managed by computational design. And as you can see, this is the ID number. So again, in the UAE, without any problem, we could collaborate for the on-site construction. So this is the key diagram. What is a regenerative wood? So we use wood waste for the materials, and we use 3D printing for giving the freedom in a form and also production. And we use Japanese joinery for the joint system for the small components. And we use computational design to control all the different shape of the components. So we all combine together. Then again, like finally we can reach some of the variable design concept, what we call the regenerative wood. So when you look at the forest circulation, every time, when we create a timber or any wood furniture or any kind of wood products, you always create wood waste, which is a wood powder or a small piece of wood waste. But we would like to give market value to the waste by using design or upcoming emerging technology. So we utilize wood waste and then turn into the wood pellet for the 3D printing material. So in a way, we turn wood waste into variable building parts. So this is an example of what we achieved. So we have the brother company called MEC Industry. So this company producing the timber material and also CLT or also design product as well. But each time they create the wood waste, which is a wood powder. So we turn wood powder into wood pellet, and we 3D print, and then we create, for example, like tea house. So when we look at the recent cost benchmark in 3D printing housing, so apparently utilizing 3D printing for the architecture has a big potential in terms of the construction time and cost as well. So for example, for this project in Portugal, printing time is 18 hours for one house. And for Japanese example, 40.5 hours, which is very short. This is why the construction cost is very low. So we can say the what's a good point of the 3D printing technology is we can reduce cost and time, construction time, and labor costs as well. And also we can reuse and also recycle the material, so it can be very eco-friendly. And we can easily create the complex geometries without any formwork. But most importantly, the 3D printing is very accessible for the accessible fabrication technology. So, for example, for the desktop 3D printer, for example, small studio or workshop or even student can use 3D printer nowadays. So this accessibility is very important for the future architecture production through the digital fabrication. So we actually took the completely opposite method compared to the what we can see in the world. So this is a kind of like you can see many examples in the internet. Many companies actually trying to use 3D printer, the same size as a house. So meaning like large scale 3D printer producing large scale architecture, and also using concrete material. On the other hand, our regenerative wood technique is using very small 3D printer, but using many 3D printer, and producing many small components just assembled together by some traditional joinery system. And also for the large scale 3D printer has some limitations. Of course, the concrete and large scale 3D printer, what you can see in the internet, is very powerful, it's very strong production system. At the same time, the layer height is very thick. So, for example, if you want to create very fine detail of architecture, it's very difficult to achieve. And also, this huge 3D printer itself is very expensive as well. So there is a limited access if you want to use this 3D printer. At the same time, after construction, if you want to change some layout or walls, or if you want to maintenance and also like change the layout of the housing, it will be very difficult because all the structure is entirely connected. But at the same time, desktop 3D printer has very completely opposite characteristic compared to the large-scale 3D printers. So very cost-effective and accessible and very precise printing technique, and also very flexible in terms of the shape and material as well. So we come up with this idea, what if we could use many small 3D printers to produce architectural scale projects, not using large-scale 3D printers? So when you create many small-scale architecture parts, components by small-scale 3D printers, how are you going to create big-scale architecture? You need to combine together. We need to join together small piece to the big-scale envelope. This is why we come up with this idea, a Japanese wood joinery. And Japanese wood joinery system, in general, we use for the traditional temple or housing back in the old days. And we always use this technique for the linear structure or straight structure, like a column or beams. But at the same time, if we could use 3D printer, we can actually utilize this complicated geometry of the joinery to the double core panel components, and without any problem. If you want to do this if you want to create complicated geometry on a double curved surface by hand, you will take like year for each panel. But for the 3D printer, they don't complain, and they work 24/7 every day. But this is why we could reach to create more than around 1,000 different shape of the panels for the Dubai Design Week. And also we could create the, because of all the panel components has different shape. And also we need to give a number for the easy construction. So this is why the computation design was very important. And then we could establish the entire workflow to control all the different components and also giving an ID number for each components for the 3D printing production. So in the end, we could fabricate about 3,000 different shape of the components and about 988 panel components and also 1,938 joint components like this. This is the 3D model of all the components. And this is a assemble process, what we done in the Dubai Design Week actual. So this is a design to assembly workflow, what we done to the Dubai Design Week. So firstly, we design somehow nice design surface in a Rhinoceros, a 3D modeling software. And then we will give input to the grasshopper. And this grasshopper will automatically divide printable panels and also automatically create Japanese jointly at the edge of the panel. And they will control and manage and then also giving the ID number automatically to the panels. Then wood waste will be the material and then we 3D print. And then because of we use desktop 3D printer, we can put in the standard shipping box. And then we send to the UAE from Japan. Then we, and a small team could construct in few hours. And very easy because they need to follow just number. They don't need to require any special skill for the construction. So it's more like a Japanese Lego system in a way. So we experienced several prototypes and we are looking forward to expand this technique, regenerative wood, for the pavilion, for the architecture and interiors and furniture and artwork as well. But somehow, to implement real-world architecture project, there are some challenges. So we need to make sure for the better fire safety and also weather thermal resistance and long-term durability as well. So, and also we need to more strong structures, strong panels, strong jointly. And also we need to think about how to integrate with a different material, which is glass, steel, concrete, any kind of insulation, familiar architecture materials. And this is what we're looking for in the future. So we're looking for to create and also utilizing this 3D printing regenerative wood system to the real housing project as well. So in this project, we would like to reach the integration of the different materials, wood 3D printing components and glass and insulation and concrete as well for the floors. And also we are looking for the mass project as well. So again, if you want to do construction, large 3D printer on mass is very unrealistic because how to bring large-scale 3D printer to the mass. But if we use the small-scale fabrication machine and also utilizing local material and then combine those components, those components by robots. Because human cannot construct because of the gravity or harsh environment, but robot and machine, small robot and machines create our planet, our habitat on the Mars in the future. So this is why this regenerative wood 3D printing system is very, I think there is so much potential for the Mars project as well. So as a final, this is the 3 key takeaways from today. So waste can be resources by using upcoming emerging tech. And also tradition as a design logic. So we can learn and utilize and steal tradition knowledge by combining design fabrication. And also, architecture can be a circular system. If you can create a very flexible structure like Tsuginote tea house or the warp, we can always recycle, and also we can always make circular ecosystem. So this is why architecture can be circular system in the end. So I think the future of the wood lays not only what we build, but in how we build it. Thank you.
So now I got inspired to make my own timber house and put the tea house inside of it. All right. So I think now we have a lot of questions here, right? So if you would like to ask the questions, please raise your hand up. All right. Okay. So the first question here.
Okay, thank you for the inspiring presentation from both of you. I'm from Department of Architecture, and I have a question for Mr. ATSUMI. I can see that there are so many advantages of using 3D printed wood. It's eco-friendly. You can design free-form shape. It's reversible. You can transport from one place to another, and that's great. I have just some technical question, like how do you transform the wood pellet to filament, because you use 3D printers, desktops, right? And how long it takes you to print with how many printers?
Yeah, thank you for the good question. So this wood filament material is 30% wood waste powder and 70% bioplastic, and we combine together. Of course, this percentage can be lower and higher. Of course, depend on the factory of the 3D printed fillet. And for example, for this one, Tsuginote tea house, we utilize the 6 3D printers. And
Six only?
Yes, took 2 months.
2 months.
Actually, it was my master thesis project. And
Okay.
for example, the warp was about 15 desktop 3D printer we used, and it took 1 month
Oh, 1 month.
production.
Not too bad. Yes, and I have a further question. Do you run any optimization for the structure? For example, structural optimization or number of panels? Because you have like 900 of them.
Yes. For the structural optimization, because it was very rushing project, I designed only in 2 weeks or something. So this is why I couldn't do structural simulations. But of course, when we gonna create housing, real housing, of course we will do simulation as well. And for the optimization, all depend on the how big your desktop 3D printer. Because once you create the design surface, the grasshopper will automatically divide your 3D printer building volume. So depending on how big your entire envelope and how big your desktop 3D printer, then panel numbers will be different.
Okay, thank you very much and
you very much.
congratulations.
All right. So we have another questions up here. All right.
I thank you for the talk. I just like to ask further about the material. You say that is like 30% sawdust, right? Why not like using more waste material, like pushing it up to 60, 70?
Yes, of course, we would like to reach the 100% for sure. But if you gonna reach to the higher percentage, probably the stability or material performance will get lower, I think. Of course, if you could give the big pressure when you create the 3D printing material pellet, then maybe you can you can reach to the higher percentage. But usually, when you're going to use the more than 50% or 60% of the used sawdust, the printing stability will get lower and lower. This is why, so it's all depend on the printing quality.
You say the printing stability, not the material stability. Is that right?
Yes.
So material-wise, how is the regenerative wood different from like the current WPC, wood plastic composite?
I think almost the same.
So it's pretty much the same. You just like
Yes.
have more flexibility in terms of the shape, right?
Yeah. Yes.
And another question about the joinery. Which type of Japanese joinery you use for the project?
Yes. Mainly. So this is a joinery type. What we used always. This is a ryakukama. This is hard to pronounce. Ryakukama and sen. So we combine two traditional Japanese joinery into one 3D printing joinery, ryakukama and sen.
But this joinery usually like traditionally used for like a mass larger timber.
Yes,
right?
exactly, for the temple or any kind of wooden housing.
And for this project, would it like bear the load of the weight of the material as well? Or the joinery is like just used for assembly and disassembly? Do they like carry the load?
Of course, maybe a joinery itself carry the load, but this 3D printing panel itself very lightweight, extremely lightweight. This is why mainly this joinery keeps the and joint between the panels.
All right, thank you. Maybe just one more question for the second speaker. I'm curious about the in terms of investor who would like to invest in building the building with the mass timber. Would it be like more attractive? I mean, the cost of constructing the building from timber, is it like more expensive than say pure concrete and steel, and plus the maintenance costs and perhaps shorter lifespan? Would it like overall more attractive for like investor?
Yeah, actually, regarding the cost, current mass timber takes more cost rather than the pure steel or pure concrete structure. However, for that project, client has very strong motivation to create the timber buildings, because currently the Japanese mountain forest has timing to regenerate. So many people is concerned about the future mountain forest, and clients try to activate the timber market as much as possible. Then they decided to create a very mass timber building in front of the Tokyo station, even though it takes more cost rather than the steel structure. So that project is kind of the showcase to show the possibility of the mass timber as the kind of the challenging phase of the mass timber trend all over the world.
Okay, thank you.
Thank you very much for the questions. And we also have another question. All right. Who raised first? Okay, let's go to the closest ones.
Thank you so much for the wonderful lecture. We learned a lot from all of you. And I have a question regarding as we are currently at the age of environmental disruption with so many disasters like flooding in Chiba Prefecture or the earthquake with more than magnitude of 7, like 11 places worldwide. How would mass timber structure and regenerative wood made dwelling could be response to this kind of uncertainties?
So let me talk mass timber first. Actually, timber is an organic material. So if the timber structure is facing to the flooding, it's not a good situation. However, why we use the timber is how the building construction will become the eco-friendly more than before. So what's the solution for the uncertainty in the future is knowing the material property as much as possible and using its the appropriate portion. I think that is an important thing to use the many material, even if it is a steel, even if it is concrete. So for the Tokyo Marine project, compare the strength itself between steel and the timber. The steel is much more stronger than the timber. But using the base isolation system and mitigating the inputs seismic earthquake load to the timber, then we can create that kind of the timber structure. So the answer is how we optimize, how we use the material at the proper position. Then and how we imagine that kind of the uncertainty and how we provide the double, triple treatment, a countermeasure for that kind of uncertainty, I think.
For the utilizing of 3D printer, so for example, this one is a kind of like a Japanese version of Lego. So anyone can construct in a few hours. So for example, imagine like after earthquake and disaster, everyone will evacuate to the certain place. But if you could use this system for the emergency housing creation, that will be anyone can build your own house, a temporary housing. And also, if utilizing 3D printer, it's actually standardized the quality of the output. So, for example, if other country except Japan has the level 8 or level 7.5 of the earthquake, all the building will be very damaged. But Japan is, because we prepare so much of the earthquake, so our building is relatively stable. So, for example, we can implement our Japanese structural engineering technique using 3D printer to the other country and then keeping same quality. That would be very useful way for the future of architecture.
Thank you. Thank you so much.
Thank you very much for the questions. So, do we have other questions here? All right. So we have the probably gonna be final question.
So I have a question for like these projects. I see you mostly put them like outdoor. From my student perspective, understanding wood might not be the best like suitable material to stay outside, and I believe some plastics also have like expiry dates. So I would like to know like how can this pavilion also like tackle these problems, and as these are like materials that have been reused from waste, how does after this one serves its purpose, will it not turn into another waste? Something.
Thank you very much. So again, this is a wood-based recycled plastic in a way. So this is not suitable for outside usage, and because this is just the device that we could exhibit to the outside, but as you can see, right now Tsuginote tea house is downstairs in the inside. So if you use plastic, the outside usage is not suitable for sure. And but currently we are actually developing to utilize 3D printing technique for the fireproof material or heat-proof material, meaning we utilize 3D printing technique to give the shape, which is using as a mold and casting concrete or recycled concrete or recycled terrazzo, for example. Then we can utilize complicated double curve shape to the outside, but still using 3D printing technique. And this one, after this, you can assemble a few hours, disassemble a few hours, and you can crush again, and then create a new pellet. Then you can create another any tea house in the future. So this is also interesting upcycle example.
Thank you very much.
So do we have any questions? The very last chance. Okay, sir. If we don't have the question from the audience, I have one question. The timber structure is kind of new. Like for me personally, if you want to build a mass timber structures, usually we use the steel and concrete, right? And you also have a lot of projects for the mass timber structures. I would like you to share which line that's your customer closets to change from the structure of the steel and concrete to be the timber. Do you have to convince them, or they just okay, I really want to do it. I quite passionate for the timber. Probably yeah, because you have a lot of experiences for the mass timber structures. Maybe you can share the design phase or the decision phase with the audience. Yes.
To be honest, I'm still looking for the boundary between appropriate scale for the timber structure and the steel structure. And also it's depend on the building occupancies, and many reasons, many factors to decide what is the appropriate structure system. So, but recently, many clients and people is very interested in using the timber, and so I feel we are still in the challenge phase. So during the challenge phase, if the budget allows, as engineer, I try to facing that demands honestly and try to generate the new possibility. So maybe near future, I would like I will have some kind of the boundary line for each occupancy. But so far, I'm still in the challenge phase.
Thank you very much. All right, sir. Do you have any questions here? All right, sir. Thank you very much for. Please give a big hand for our speakers. Thank you very much. Thank you very much.